Arnaud Lacourt is the CEO of UBESS, entrepreneur in beekeeping and technologies. And Arnaud, you're an entrepreneur who combines 20 years of extensive international experience in the technology industry with vast knowledge of beekeeping in Europe. So now let us know more about your company, and you have exactly 9 minutes to do.
Well, thank you, Audrey. Thank you, Maëlys, and for the chance to introduce what we do with sensors in order to save the bees. So next slide, please. So as you know, the bees are really important for our survival, as they are essential in the reproduction cycle of 80% of the flowers on Earth, and which is about 1/3 of the food that we are eating directly. And you can see on this picture the impact of the collapse of the bees on the supermarket fresh products. Next slide, please. Unfortunately, we have seen a decline that has been very regular in the past 30 years of the pollinators, of the wild pollinators worldwide, with, of course, some differences between the different countries and continents. But as a general rule of thumb, let's say that we have seen between 60% and 80% of disappearance of those wild pollinators on Earth in the past 30 years. The problem we have is that we have planted twice more crop in the same period of time that are purely dependent on the bees. So it has accelerated this shortage of pollinators. Next slide, please. So at UBESS, what we do, so we have created the company in 2017. The company is headquartered in New York. We have operation in California, in the Central Valley, to do pollination, operations in the Midwest, and we have started to do coffee pollination in South America. And we have a software tech office also in Paris, where we do the IoT research. Next slide, please. What is important with bees is that is to monitor the population dynamics, the demographical dynamics of the colony. It's more than 50% of the work of a beekeeper is to open his hive and look at what is the size of the population I'm getting in this hive, and what are the reasons why it's not developing that fast. So what is important is that the bee population is inside a hive is fluctuating a lot during the months of the year between winter, spring, and summer. And what is also very important is that the work that a bee is doing is not the same during the different ages that she gets. So when a bees get born, she's going to start to work inside the colony. And after a while, she's going to be a nurse bee. And at the end of her life, which is going to be the last 2 weeks of her life, she's going to visit flowers and do this pollination efficiency. So what is really important is to monitor the number of foragers, so the number of senior bees that we call also the elite bees, because that's those bees that are going to work the flowers and ensure this reproduction cycle. Next slide, please. So what we have developed in UBESS is a sensor that you see in the middle of this picture, which is a bar. It's an IoT system made of 5 different temperature measurement, 1 humidity, that we put in the surface of the frames. So we are able to monitor the temperature in the different area of this surface. What is really important is to monitor the thermoregulation of the hive, because the bees, when they are in enough population in the hive, they're going to try to keep a stable temperature between night and day, because the brood, which are, let's say, the eggs, needs to be kept at a stable temperature of 34 degrees Celsius. If you get variation of that, it means that you don't have enough bee population to cover the full size of the beehive. So with a mathematical model and the machine learning system, we have taken this data, analyzed the thermoregulation in the different parts of the colonies, and extrapolated the number of bees, the number of foragers that are the useful bees that we are looking for. Next slide, please. I can show you very quickly an example of project we are managing right now with Nespresso that we manage in South America, where we put in application those systems in order to track this pollination effect on the flowers. So just this slide to illustrate what are the changes that are impacting the coffee farmers in South America, which are influenced by both the climate change, a change in temperature, but also a collapse of the bee population within South America. And as you can see, we estimate by 2050 that there will be an impact of about 1/3 to 50% of all those places that will not be suitable anymore to grow coffee. So a huge impact also on food system, but also on the resources of those very small farmers. Next slide, please. So what we have developed in partnership with Nespresso is to re-implement a small quantity of hives within the farms of the small coffee farmers. So we put few hives, 20 of them in each farm. We train the beekeepers to maintain those beehives alive. We install the technology to help them because they don't know nothing about beekeeping. And also we trace the chemical around. And we have two objectives. One is to increase the pollination effect, so to increase the yield. We have good results, 15% of increase of the yield of coffee directly impacted by this surplus of pollinator that we re-implement. And also it generates additional revenues for the small farmers. We increase their revenue by 25% because they're going to sell the honey outside of those hives. Next slide, please. And we are implementing the technology inside a hive. So first, to help them to monitor the hives, because that's a new management that they are discovering. And the coffee farms, they are in remote locations. So it's difficult for them to get there. So with remote monitoring capacities that we got through LoRa networks, so it's an IoT systems, they are able to know every day how the bees are going, is the colony growing, what my bees are doing, are they flying today, and what is the progress of the pollination of the flowers or of my field, so I can monitor exactly where I am during this blooming period, which is very critical for the crops. Next slide, please. On top of that, we are also monitoring another system. We don't do it by IoT today. We do it manually because we take samples also in the beehive where we collect pollen, wax, and honey. That is useful for us in order to monitor the level of chemicals that are exposed in this area, because the bees, they are scanning every flowers in the area. So we are able to scan the level of chemicals that are exposed, but also the biodiversity of the environment. What we do in Colombia is that we have implemented the bees in agroforestry ecosystem. So there is also a little bit of wild, I would say, rainforest around the bees. And that's very important for the bees to get a good diversity of pollen because it gives them a higher chance of survival through, I would say, the difficult period of the year. And we are having very good result in the rainforest because the bees are collecting 4 or 5 pollen at the same time, which give them many more chance to survive over the year. And next slide is just my conclusion. So if you have any question, please feel free to ask.